Hello, well done for making it to the end of another week. So today we've got a couple of starters as usual, and then we're going to recap what we've been doing this week on area. Okay. So first of all, Cal worked 40 hours last week and got paid £374. How much did Cal get paid per hour? Now, you probably would want to reach for a calculator, but the first thing is it's important that you know what buttons to press on a calculator, and then we're going to do it without a calculator. Okay, so altogether, Cal got paid £374 for working 40 hours. So if we want to know what he got paid per hour, we're going to have to do a divide. 374 divided by 40. Okay, so at that stage, you can press buttons on a calculator, or you can just think, no, it's okay, I know how to do this without. So you do 374 divided by 4, and then divided by 10. Because dividing by 40, you need to divide by 4 and divide by 10. Okay, so let's do the 374 divided by 4 first of all. So 4 into 3 doesn't go. 4 into 37 goes 9 times. 9 fours are 36, so we've got 1 left over. 4 into 14 goes 3 times. 3 fours are 12, so we've got 2 left over. But remember, when we've got nothing to carry it on to, we can put a point 0, and now we can remember to keep our points in line when we're dividing. And then 4 into 20 goes 5. Okay, so we've got 93.5 for the answer to this bit, and then we need to divide that by 10. Okay, so remember to divide by 10, we're moving the digits one place to the right, so that would make it 9.35, and remember it's money. Okay, so not too tricky. We've got all the skills to be able to do that. And then the next one, how long would it take to run 5 kilometres if you ran at a steady pace of 6 minutes per kilometre? Okay, so for every 1 kilometre, it takes you 6 minutes. Okay, so how we're going to work out how long it would take to run 5 kilometres? Well, it's just going to be 5 times as long, isn't it? If 1 kilometre takes you 6 minutes, then 5 kilometres would take you 5 lots of 6 minutes. So it would take you 30 minutes. Okay. That's about the speed that I run at, and I'm building it up. So I'm not particularly quick at all. And I'm building it up to being able to run 10k. That's something that I've been trying in this lockdown period. Okay, right. So today we're going to look at all the areas that we've looked at during the week. We're basically just going to work our way through a set of shapes and find the areas of them all. Okay, now before we do that, I've got a little task here to match each shape to its area formula, because if we're going to find the areas of shapes, we need to know the formulas, don't we? So let's, well, which one do you want to start with? Why don't you pause it, do it yourself, and then come back in a second. So what we need to do then is, let's see, which one shall we pick to start with? How about the rectangle? Okay, so we've got a rectangle down here. What's the formula for the area of a rectangle? Which one is it out of these? Okay, well, if you spotted that it's length times breadth, you're right. Okay, next one. Let's say the triangle. Which formula out of the ones that are left is a triangle formula? Well, we know it involves a half, but no D's involved in a triangle formula. So it's this one, isn't it? Half base times height. So let's put that one with the triangle. Then, what about this one? A equals L squared. What does that mean? Well, the clue is in the formula there. Squared So that one's the square, because remember you do a length there times a breadth, but in a square the length and breadth are the same. Okay, what I should have done on that one that I'd meant to do was mark that all the lines were the same length. Okay, right, next let's have a look. Let's look at the parallelogram. Okay, so the parallelogram, remember, because it's kind of slopey, a parallelogram, you use this line, but you don't use that line for finding the area. Remember, it's that line you use. It has to be at right angles there. So I'm being careful not to use the words that are in the formula, but I'm sure you know that the area of a parallelogram is the base times the height. Okay, now actually we've got two formulas left, look, and they're both the same as each other. And that's because the formula for working out the area of a kite and a rhombus, they're exactly the same formula, because a rhombus is a special kind of a kite. Okay, so that's all the formulas that we might need today. So let's find our shapes now. Where have they gone? Oops, Daisy. Where have they gone? Come to beginning. Right, so we're just going to work our way through these. Okay, so the first one, we've just got a rectangle here. So each time we're finding an area, we're going to write down the formula. So remember, area of a rectangle, that we just reminded ourselves, is length times breadth. And then we stick our numbers into our formula. So the length is 13 and the breadth is 6. And then we need to work out 13 times 6. So we can just do a chimney sum if you want, or do it in your head, don't mind. So 3 6s are 18, 1 6 is 6, add the 1 makes 7. So 13 6s are 78. Our lengths were in centimetres, so our area must be square centimetres. Okay, the next one. Here we've got a triangle, so we'll write down our formula. Area equals a half base times height. Remember, for a triangle, the base and the height have to be at right angles to each other, and that's the situation that we've got here. If the base is 16 along here, then remember the height of this triangle is not that length, and it's that length there, and that is 12. So it's a half times, so the base is 16 and the height is 12. And remember, when we're working out these amounts, we can halve whichever bit we like and then multiply it by the other one. So why don't we do a half of 16 is 8 times 12, 8 12s are 96. And the lengths were in millimetres, so our area will be in square millimetres. So our next shape, as we have a look here, so we've got a kite shape. So if we write down the formula for a kite, or the area of a kite, sorry, it's a half d1 times d2. Now, remember, d1 and d2, they're the diagonals of a kite, okay? And if I just draw them in, there's that one, and there's that one. They're the diagonals of the kite, okay? Now, we don't have those lengths marked within the kite, but we can see outside the kite that one of the diagonals is 120 and that the other diagonal is 50. Okay, so we're doing a half of 120 times 50. Okay, and again, it's up to us what order we do this in, but I would suggest that a half of 120 times 50 is probably the easiest. So we've got 60 as half of 120 times 50. So remember, when you're multiplying by 50, either times by 100 and half it, or times by 5 and then times by 10. So 60 times 5 is 300, and then times by 10 another 0 there. The lengths are in metres, so the area is in square metres. Okay, and our last question for today, so it's just been a wee short recap today. Our last question is a parallelogram. So remember, the formula for parallelogram is base times height. So we can see that the base is 1.8 and the height, well, it's either 1.1 or it's 1. Which one of those is at right angles to the base? Well, it's that one, isn't it? It's the 1 centimetre one. So it's 1.8 times 1. And remember, anything times 1 is just itself. So that's 1.8. The lengths are in centimetres. So the area is in square centimetres. Okay, so that's us finished with area now for this week. So we've looked at areas of all different shapes. Next week, we're going to go on and look at areas of composite shapes, which are what you get when you put more than one shape together. Okay, have a great weekend. See you later.